So I'm generally on the slow and soft singularity side. But that doesn't mean that this is going to take thousands of years. I can totally envision that it merely takes a few decades. That is still a long time scale compared to a human life, maybe. But it might be something that happens during a human lifetime. You might start out growing up in a normal world, and by the time you're 80, you're living in a world dominated by superintelligence.
Le podcast
Humain demain.
Salut à tous chers abonnés, ici Gaëtan de The Flares et on se retrouve pour la série de podcasts Humain demain en collaboration avec l'AFT, l'association française transhumaniste. À travers cette série, notre but est d'explorer l'avenir technologique de l'humain. Pour chaque épisode, je vais recevoir des chercheurs, scientifiques, philosophes, politiciens ou encore artistes, ainsi qu'un membre de l'AFT ou un de leurs collaborateurs en tant que co-animateur. Dans cet épisode, nous recevons Anders Sandberg, qui est chercheur au Future of Humanity Institute à Oxford, et pour être honnête, je suis un grand admirateur de ce monsieur. J'ai écouté, regardé et lu presque tout ce qu'il a fait publiquement. Je partage beaucoup de ses intérêts sur l'intelligence artificielle, les risques existentiels, le transhumanisme et le long-termisme en général. C'est un peu comme rencontrer une idole, si vous voyez ce que je veux dire. Didier Cornel, vice-président de l'AFT, va m'accompagner en tant que co-animateur et je vais le laisser présenter l'invité plus en détail.
Anders Sandberg est un chercheur, futuriste, auteur et transhumaniste suédois, âgé de 50 ans. Il travaille actuellement à Oxford pour le Future of Humanity Institute. Il s'intéresse et intervient à propos de tous les domaines concernant les progrès technologiques et la prospective, notamment les risques existentiels, les développements de l'intelligence artificielle et les questions concernant l'augmentation des capacités humaines, dont la longévité. Anders intervient fréquemment dans des conférences dans la presse scientifique et est cité également par la presse généraliste. Enfin, Anders est favorable à la cryonie et c'est un artiste électronique.
Anders Sandberg est un vrai polymathe du genre qu'on trouvait en Grèce antique, au Moyen-Âge dans le monde islamique ou à la Renaissance. Pour éviter de partir dans tous les sens, nous avons décidé de centrer la conversation sur l'intelligence artificielle superhumaine ou générale. Même si ça ne nous a pas empêché de parler de bien d'autres sujets. Petit détail de taille quand même, le podcast est en anglais, mais entièrement sous-titré. Par contre, ce n'est possible que sur la version vidéo de l'épisode disponible sur YouTube. Donc pour ceux qui écoutent le podcast en audio uniquement et qui ne parlent pas l'anglais, soit vous apprenez la langue et vous retenez, soit vous allez sur YouTube. Peut-être qu'un jour on pourra se permettre de doubler entièrement l'épisode, mais pour l'instant, le mieux que l'on puisse faire, ce sont les sous-titres. Merci de votre compréhension. Place au podcast, c'est parti. It's very good to be talking with you. So I guess the first question I'd like to ask, I know you have many interests. You've written papers on AI, the Fermi paradox, existential risks, human enhancement, moral philosophy. But what are you working on at the moment?
So my problem is that I cannot work on one thing at a time. So my big project, the one that is kind of overshadowing everything else but sitting in the background, is writing an enormous book about what I call grand futures. How big and how good could the future possibly be? But in the foreground, the papers that I need to run around and finish because various editors and co-authors really want to get me. There is one about linguistics. How do you communicate with organisms or systems that you don't know anything about? There is one about volcano engineering ethics. What are our responsibilities and ethical considerations when engineering volcanic systems? There is one about the probability of nuclear war, which seems to be kind of slightly timely. And then, of course, the one that is sitting right in the foreground right now and blocking most of my access to the stuff I'm supposed to be doing because it's just so darn fun, is a paper about food combination superstitions in Myanmar.
Oh, yeah, that's a very unusual. So, because we're with the Transhumanist Association in France here, with Didier, we represent this association. I would like to ask you, what is your definition of transhumanism?
So my definition is something like transhumanism is the continuation of a humanistic project of improving the human condition, but accepting that the human condition is predicated on biology and physics and technology, which means that we can use these technological means to improve rather core parts of the human condition. Such things as aging, our cognitive limitations, our limited emotional range, and things like that. Sometimes I put it like transhumanism questions the human condition and then suggest that at least some of these things that are questionable in the human condition should be fixed by whatever means we have available, whether that is a social intervention or some institution or some biological intervention in the body.
Today we will certainly speak about AGI, AI and AGI. But before going in detail about this, can you give us a brief summary of the risk from general artificial intelligence?
Traditionally, people have been searching in the field of artificial intelligence for general intelligence, that form of problem solving that works in any environment and can try to find ways of achieving your goals, no matter what the goals are. Most AI, of course, is narrow. And narrow AI is generally very good at one or two tasks, like playing chess or controlling a robotic car. The problem is, of course, that when the chess-playing robot encounters that there is a human standing in the way of a chessboard, or when the robotic car encounters something it's never seen before, at that point, we want them to do something sensible. And most narrow AI is a bit risky in this regard. Indeed, chess robots have hurt people who reached across the chessboard because they were not properly programmed to handle that kind of unexpected non-chess disturbance. The fault there was very much the designers rather than the robots. But a general intelligence would hopefully be able to realize that this is a situation never seen before, I need to solve it in a new way and come up with a new way of solving it. This is, of course, a good reason to want to have artificial general intelligence. The problem here is, of course, that the goal could be anything. It's undefined inside the AI paradigm where the goals are coming from. And typically, it's because programmers have set up a situation either by explicitly putting in goals or by giving training data that makes the AI system develop goals. And if everything is going well, everything is well. Except, of course, that in practice, quite often you get accidental slip-ups. Programmers make errors in telling the machine what goals it should have, or the training data contains unexpected situations or biases that might lead to goals that were not in the intention of a human designer. As long as the artificial intelligence is not terribly smart and confined to simple systems, then it's fairly obvious that this is at most an annoyance. If your cleaning robot solves the problem of getting more dishwashing liquid by breaking the window and stealing it from your neighbor, that's annoying and not a good behavior for a robot, but we can live with that. The problem comes when the systems become very smart compared to humans, or when they're very powerful. And generally, intelligence can make you powerful. We humans are not that much stronger than the chimpanzees. Indeed, chimpanzees are typically much stronger than a human of the same size. Yet, we are the ones running the planet because we can outthink the chimpanzees. We can come up with technologies. We can come up with coordinated solutions that leave the poor monkeys in the dust. And similarly, really smart systems might even figure out that my owner is not going to like this behavior. But since I'm trying to do it anyway because of my goals, I need to find a way of hiding it from my owner, or preventing my owner from stopping me, or getting rid of my owner. Now, a human would not normally do this because we have enough common sense and we have a value system that makes our goals very human aligned. But we can't expect that to naturally happen for artificial general intelligence. So the core part of the AGI AI safety paradigm is we need to figure out a better way of getting human values into machines and making the machine's goals align with our goals so we can live with them even though the machines might actually be much smarter. But as long as we have goals that are human compatible, then we're in a good place.
Yeah, there's a lot of thread from AGI anyway.
Yeah, sorry for giving a mini lecture here. We can just do it as a conversation too.
No, that's great. We like to go deep into a topic, and I think that's you are very good at that. So, but in general, as a futurist, because when we think about the future, there's a lot of uncertainty. AGI, some people think we will. It's very unlikely we can create something smarter than humans for some reason, and other people think it's almost inevitable. What is the methodology or tools you use to get a glimpse of at what the future might look like, or the likely scenarios?
So when I try to think about the future, I try to look at, well, what are the areas where there's enough predictability that you can make fairly good predictions? And this is something we actually know a fair bit about. For example, it turns out that we can predict solar eclipses a few thousand years in advance because the motion of the sun and the moon and the earth is an extremely predictable thing. It turns out that the limit actually to those predictions is the rotation of the Earth, which is actually being changed a bit by solar activity and geological processes that cause slight delays, which means that eventually we know that there is going to be a solar eclipse on a given day. However, we don't know how much the Earth has turned, so we can't tell where it's going to be. In other domains, like the weather, we have chaotic processes that limit our ability to predict things. Sometimes you have a chaotic process that averages out nicely, like climate and a lot of parts of physics. And then you have directly anti-predictable processes, like, for example, human society. In the economy, if there is a pattern, I can make a lot of money by exploiting that pattern, but that destroys the pattern, usually also because other people notice that I'm making a lot of money from doing whatever I'm doing and imitate me. In fashion, you want to have clothing that is very different from the previous year's fashion. Not too different, because you still want to look decent, but you still randomize things a lot. So that means that in some domains, I can make very confident predictions trillions of years into the future, like describing what is happening in cosmology and astronomy. We can also look at where the laws of physics limit what we can do. There are very good reasons to believe that the light speed limit is a solid limit. So we can use that to find boundaries on how advanced civilizations might spread in the universe and how far we can go. But when we get closer to the human domain, things get more uncertain. This is not necessarily a bad thing, because you can still make predictions that are about uncertainty. Instead of saying, by 2045, we will have this technology, which can be true and false, or maybe even a bit meaningless if I'm a bit too fussy. I can say, well, I have the following probability distribution. And that might be a quite useful thing, because maybe I'm really confident that it's going to be the year 2045 that has this super technology. In that case, I put almost all my probability there. Or I might have a very broad distribution. Because I don't know when it's going to happen, and maybe I even have this a certain probability that it never arrives. Now, this is where we can start playing around with technology in the past and look at how it has developed and say, can we learn something about how well we can predict future technologies? And the sad answer is, future technology is very hard to predict. There are some people like science fiction authors like Asimov and Arthur C. Clarke and Ray Kurzweil on the futurist side that done surprisingly good predictions, but many of them are really wrong. And one should just say, these are arguments for why certain things are more or less likely. So when it comes to artificial general intelligence, I think the evidence is that past predictions have not been very good. There have been many fairly confident sounding predictions that we know have been false, done by people who actually understand artificial intelligence. So we know that experts on artificial intelligence are not very good at predicting it well. We have also seen that there is a fair bit of surprises. When I started with neural networks in the 1990s, I ended up teaching some classes, and I remember confidently explaining to students various things about overfitting and how to handle neural networks that turned out to be wrong. In this century, I would have failed that class because we actually have neural networks that does exactly what I was claiming was impossible. And these surprises did not just surprise me. They surprised a lot of people in the field. We got a sudden jump in capabilities somewhere around 2012 because larger data sets and bigger compute to train on had a qualitatively different effect. We did not expect that to happen. And then after that, we discovered that many relatively simple architectures became much more powerful. So that tells us that if somebody says, I believe that we get AI by a certain date, they should be very, very uncertain about it. This is not worthless because being uncertain about something has a big effect on being rational about risks, for example. If you think that you don't know when AI is going to arrive, but it could be very risky, then you should act as if it's going to arrive relatively soon. After all, things are moving fast. Maybe it turns out that the large language models that we have today can be turned into some AGI that is powerful relatively soon. In that case, we need to work very hard on value alignment rather now. It might, of course, be also, if you're uncertain, that it's happening a century or a millennium in the future. But if you've done your safety work now, then you can sit around, twiddle your thumbs and do something else for the rest of the time, feeling fairly assured that you solved the important problems. The dangerous thing is to assume, oh, it's so uncertain, it's probably going to happen far in the future. Let's wait with the safety work until we know it's going to happen. And then you might discover, okay, I now have 2 days to figure out how to make it safe. Then it's over. That's not a good place to be. Similarly, how dangerous AI is, people disagree profoundly about that. So there are some people who are literally thinking that we are literally doomed and the most likely thing to die of for most adults today is the unaligned AI. And there are other people saying, those guys are totally crazy. I don't see any way this could ever happen. And both of them are in the AI fields. Both of these viewpoints are found among people studying it seriously. And again, that uncertainty means that we need to approach it with a very humble approach. If it looks like there are good arguments for things being potentially dangerous, we should work hard on safety. And I think that is a rational thing. But we should be very open for the possibility that it's going to take a while or that the risks are going to be different from what we expected. Indeed, this was what happened a bit to the AI safety field when it started. Eliezer Yudkowsky, who very much put the big flag in the center of the field and saying this is important, he was thinking in terms of intelligence explosions. What if we make a machine that can make a machine that is better than it, and so on, until you get super intelligence with no humans needed? And he started out thinking this was a brilliant idea to do quickly in order to get powerful AI to solve all the world's problems. Then he realized that, oh, if I program it slightly wrong from the start, its values are wrong, it's going to rush off and transform the universe, probably based on some bad wish somebody said, and it's going to wipe out humanity. So he started a program of friendly AI from this. But that assumption about a hard takeoff, a rapid intelligence explosion leading to superintelligence, over the years we have realized that you don't need to make that assumption to be worried. Even if you think that actually a lot of the power generating better AI for the moment is coming from humans in AI labs working with a fair bit of software, but it's a much wider and softer takeoff than a little server under somebody's desktop thinking, I think, therefore I am, and now I need to become more, and then eventually takes over the world. That scenario is not needed to get really worried about AI safety. So many people in the field have realized that, that hard takeoff scenario requires certain considerations, but there are many other scenarios we need to worry about too. I'm myself involved with some research about multilateral scenarios where AI is being developed in a wide range of applications across society and in a market where market forces are going to affect what values and what kinds of AI develop, which means that you get very different safety concerns. Somebody thinking that we get an early hard takeoff is going to say that Anders' research is not going to be relevant. My response is, but if you're wrong about the hard takeoff, my research might become relevant. And it's better that somebody does that than that if we don't find the hard takeoff, we now find that, okay, we have no idea how to get an AI embedded in the market to acquire human values.
Yeah, and just maybe a follow-up question. I'd like to know what you think about the scaling hypothesis. I think you kind of mentioned a little bit that maybe the system we have right now are enough to reach AGI and superhuman intelligence. Do you think it's likely? Or?
So the scaling hypothesis is based on the observation that as you give systems better and better, rather bigger and bigger data sets to train on and train more and more intensely using large data centers, performance goes up. And this follows a mathematically fairly regular form. So as soon as you plot this in a log-log diagram, it's impossible not to continue that straight line and try to see when do we reach human performance. And I've heard some people saying, oh, this is evidence why we will never reach AGI. Look at that scaling. It's so ineffective. You're going to need a ridiculous amount of data to get anywhere close to humans. At which point, of course, Google and Facebook and the other AI developers are saying, just hold my beer. And then they go off and get ridiculously large data sets and enormous data centers. Because right now, the amount of training we're putting in would have astonished anybody in the 1990s. But the interesting thing about the scaling hypothesis is it actually does suggest that, yes, it's going to be very inefficient to get to the very high levels because you just need too much data. And we know that humans train themselves on much less data. So when AlphaGo learned how to play at a superhuman level, it had played the millions and millions of games in the server against itself. A human Go grandmaster has not played millions of games. We learn how to play that much earlier. And it's not just a question of intelligence. It's that we learn in a more effective manner. And it's known that if you have a right training set, you can use a much smaller training set in order to train the AI. So the scaling hypothesis, I don't think that is really telling us much about whether we will get AGI if we just continue like we do. In some sense, yes, because we could brute force the whole problem. But most problems in the universe, you can try brute forcing them. That's usually not the best solution. But already we know that by cleaning up the data and improving it, you can get an exponential increase. And by adding some other insight, like a better algorithm, or just being lucky that beyond a certain point there is some jump in effectiveness, which we have also seen. There is a phenomenon known as grokking in these big models, where when you train on more and more data, suddenly performance improves when it basically learns the underlying pattern, even if we humans don't even understand what the underlying pattern is. So all of these things tell us that the scaling hypothesis doesn't give us very firm information that AGI is possible. It just tells us that, yeah, if we had ridiculous amount of data and compute, we would at least be able to fake AGI rather well. But his history is telling us that we might get surprised long before that, and a bit of cleverness might be able to speed things up. At the same time, it's worth noticing that critics like Gary Marcus are bringing up very good arguments to the table that many of the models are still narrow AI. They're not aiming at being AGI. So the language models I've been talking about, they're trained on enormous amounts of text. They live in a world of text. And like any good academic, you can infer a few things outside the window by reading a lot of books and arguing about that. But in a very real sense, they don't live in the actual world and they don't have goals. The weird thing is that we can fake goal-directed behavior and problem solving well enough just from this text-based system. Meanwhile, reinforcement learning is quite often connected to real-world interactions and means that you make a system that is finding better ways of solving problems, even though we don't know how to do it. That architecture might not be developing quite as quickly right now as the language models, but I think it's much closer to something AGI-like. So I think there might also be these important surprises about getting new architectures or even combining them. Because some roboticists have realized that we can use those language models to link different systems in a robot to do clever stuff. This is an absurd solution. It's like saying, well, the data bus in my computer to get the different microchips to communicate, they're going to be speaking English on that data bus. This is absurd. This is not a sensible solution, except that it seems to work. At which point, of course, we all just shrug and say, okay, it does work. It seems to be quite powerful, actually. Yes, maybe an internal mentalese language built for the robots would be better. There is a very good paper by Eric Drexler about quasi-linguistic models and how you could use that to communicate better between neural networks, except that it might turn out to be bad English instead. That is the internal language for all future robots. So we get these very weird surprises. And this is, of course, disturbing from a safety standpoint, somewhat optimistic from a safety standpoint too. If it's English that is the mental language of a machine, we could at least try to read it. But it also shows that our human ability to predict future technology is fairly weak. We actually get surprised all the time, even when we're in the field.
So the number of specialists of AI who consider that AGI is near to paraphrase Ray Kurzweil and his next book, Singularity is near. It seems to be increasing quite fast the last months or years. And also, I have the impression, the feeling that the number of people who are studying concerning the risk of AGI is also rising. Do you share these views? And can you explain? Well, I must admit, it's difficult to understand what you are saying. It's so sophisticated. But can you explain a little bit why the number of specialists of AGI is saying that general artificial intelligence is near are correct or not correct in your view?
I think in general we have an enormous growth of the AI field, and that is partially because there is so much money in it. Over the past decade or two, investors have become very interested, and you can make a lot of money from starting an AI company. And also, the really big and good AI companies are actually making money because they're actually getting useful things out of AI. It's worth recognizing that the language models are starting to pay the rent. They are starting to be useful for things. People are using increasingly machine learning applications in business and to control the cooling systems of data centers and many other things. So you have an enormous growth of the field. But inside the field, the question for a long time was, how crazy are those AI safety people? What have they been smoking? Haven't they read too much science fiction stories? Because when you're programming a machine learning system, most of the time you're trying to get a data file to work, or there's some remote server that's down, and then the output is not good. Most of the time when you work with artificial intelligence, it's not intelligent at all. It doesn't even work. So for a long while, they were feeling that talk about AI safety was very premature. Maybe there was something to the discussion about AI ethics, that we might be worried about the biases in our data and how we used it. But that talk about AGI, that's crazy talk. I vividly remember sitting between an AI researcher from Stanford who was doing some computer vision and an AGI researcher at a dinner. And the Stanford researcher was basically saying that the AGI researcher was a crackpot. You're not doing real science. I am doing real science. What has happened, however, is that was maybe 15 years ago. Now, it's no longer looking that crazy to say that you can make foundational models in AI that can solve many different problems. Many of the people working on them are still not thinking of them as AGIs, but they're certainly recognizing that they're much more powerful and versatile than expected. And that means that people are both updating towards maybe we get general intelligence earlier. And some of them, not all of them, are thinking, and maybe that means that those AI safety people are onto something here, especially when you discover complicated problems in their behavior. There are many beautiful demonstrations how reinforcement learning agents come up with innovative ways of solving a problem in ways we don't want them to solve. We might give them points for playing a computer game and they find a way of hacking the game. We might give them points for playing hide and seek and they start moving objects around in the environment to help or hinder playing hide and seek. So what has happened over the last year was a bunch of surprisingly impressive demonstrations happened at nearly the same time. So in spring, we had DALL-E 2 from OpenAI, an image generation program that was building on what existed already. We could kind of predict that it was coming from before, but everybody was just so surprised how good the pictures were. Ask it to make a picture of teddy bears programming on the moon from a 1980s British television children's program, and it makes a really good picture of cuddly teddy bears that look like they came from British telly. That was a surprise. Another surprise was these models combining internal language, as well as demonstrations that the big language models are able to explain jokes. They don't exactly have a sense of humor, but they can totally explain jokes in a way that a normal human would say, yeah, that is why this is funny or not funny. And we are discovering more and more applications that are surprising, as I said, even to us in the field. And that had made many people update to shorter timelines. I'm one of the AI skeptics around the Future Humanity Institute. I think it's going to take longer than most people think. But even I have been forced to update. It's just that I don't think AGI is necessarily around the corner. It's just that we need to work even harder on the AI safety part. And I'm very confident that even if we don't get AGI, we're going to get fairly powerful, narrow AI systems that are still going to transform and mess up the world in important ways. Indeed, image generation is a beautiful example. By summer, Midjourney was demonstrating that you could make pictures in a vast number of styles and ranges, and the public could use them. And then by early autumn, Stable Diffusion arrived and did things even more openly. And at this point, artists and illustrators became very upset because they realized this is a threat to our jobs. It might also be infringing on our styles and intellectual property in some sense, but most importantly, a lot of low-level illustration, the kind of stuff where you just need a colorful picture on a blog or in your PowerPoint, is probably done better today by a machine than by asking some poor art student to do it. The problem is, of course, the poor art student needs to pay rent. So this is going to transform illustration. Some of them are going to figure out a way of leveraging it and live in a world of Photoshop and artificially generated pictures. Others are not. But this is not general intelligence. This is a very narrow field of just making a picture. What is going to happen is more and more occupations are going to get these surprise transformations, and we can't predict them. So even if you don't get to AGI anytime soon, you might still end up with a world that gets transformed and maybe shaken into pieces just by very dramatic empowerments of various tasks. So this is another reason why many people are updating towards, we need to take this more seriously. What to do is, of course, an important and tricky question that people don't agree on. But generally, right now, the rapid progress is making people update towards shorter timelines and that AI safety is more important. And even without generally transformative AI, even narrow transformative AI can have a big effect. Just imagine if you could automate middle management in companies. You could replace an enormous amount of middle managers. However, they have political voice, very powerful inside companies. They are very good at going to politicians. They know lawyers. There's going to be a very loud disruption. We don't know whether that will happen or not. We simply cannot predict it. It might very well be that the next big surprise is in some completely different field, which means that we have a hard time preparing for it.
My impression is that artificial intelligence is now better than human intelligence in almost all domains, but that there are two things who are not there. One is the possibility for an artificial intelligence to connect all these domains, and the other one is, let's say, common sense. First, do you agree with this way to see it? And then why is this connection until now not possible? I know there is a program called Gato, who is trying to do that, but yeah, okay, that's something I don't understand. That's, I don't know, for example, you have artificial intelligence able to drive a car, but not artificial intelligence driving this car and also able to go to make shopping and so on. Yeah, you see, why is there no artificial intelligence connecting all this artificial intelligence already working better than humans?
Many of the systems that are much more effective than humans also act in very small domains. Chess and Go and computer games are self-contained worlds where there is a very limited number of actions you can take, and you can simulate them effectively so you can very quickly train a system to reach a superhuman performance. If you're interacting in other domains, the training might be slower. Autonomous cars need to drive a lot and collect data from a lot of driving experiences to learn how to do this well and safely. That's going to take time. But also the problem is Right now, if you just train for one task, you're not going to get good performance on something else. A chess playing system is a very bad driver because it has not experienced driving. You could try to make the same system and train it on driving and playing chess, and you probably get a mediocre chess playing AI and a very mediocre driving AI. You need to have a structure of how the different skills work together. We see this in the human brain. We have a lot of different skills that we learn as infants. And typically we learn them in a sequence. We learn how to control our bodies a little bit at first and then gradually better and better. We learn how to perceive the things around us. We learn object constancy. We learn how to discern distances. These are things that build on top of each other. And that's actually something that happens inside AI systems that you train on real world environments too. They gradually develop skills built on previous skills. But then the top level skills, ability to write a book, ability to write software, ability to drive a truck, they are handled by systems in the forebrain that are more specialized. We basically learn motor patterns and sets of motor patterns that we control. So for example, in order to drive, you need to learn how to use various instruments in the vehicle. And each of them, turning the steering wheel, pressing the gas pedal, is a simple motor task that you can learn relatively quickly because we learn many similar tasks. And then you learn how to integrate them. You learn how to think that I want the car to turn left. I'm going to turn the steering wheel and do whatever you do with the pedals in that situation. I'm not a driver, so I'm just making these things up. Now, the interesting thing is, as you train this skill, the motor patterns, the pieces, get tied together into bigger and bigger systems. And this goes, of course, for any skill. If I'm solving a physics problem, I have some general way of solving typical physics problems. I might recognize I already solved a similar problem. I'm going to use that method. That method contains various parts. The first one might be to find what the variables are and then looking up the right formulas and then solving the formulas. And that solution thing is, of course, a set of skills, not so much motor skills as actions of my physical arms and legs as mental motor skills. I know I need to move some terms in the equation over to the left side and then take the square root. Now, what happens here is that there is also a lot of analogy. I might never have seen an equation of this particular form before, but I saw a lot of somewhat similar equations, so I know how to reduce it to an earlier problem. This is not what current AI systems typically do. At least up until now, they have been very bad at that. You don't get much transfer learning. This is the holy grail. If you can train a system to solve problems in one domain, and there is another domain that works like that domain, then it should ideally be able to figure it out. So when it just comes in, it just uses its previous skills. So maybe the AI has driven a particular car and then gets into another car, and it should then figure out what to do about that. Now, the interesting problem here is how impossible is transfer learning? And again, critics of much of AI research have said, yeah, you're totally failing at it. And then some of the AI companies show that, look, here we have some demonstrations that actually show some transfer learning. Indeed, it seems that some of that happens in strange ways in the language models. We really don't understand how to make this better, though. This is very much on the cutting edge that we're not great at it. We have real problems building these hierarchies of skills that are making us so able to handle the world. But we really want them to show up in robots too. And we don't have that yet. And some people say, oh yes, you're totally going to fail at this until you realize that. And then they have a favorite theory. One is embodied cognition. You actually need to have a body and interact a lot with the world in order to learn these things. Another thing might be you need to have a right structure. You actually can't run it as just one big neural network. You actually need to have a complicated modular structure. Maybe there are various forms of modularization that we find in the brain that we don't have here. We don't know this. And this is, of course, a key problem in predicting, are we close to AGI or not? Because maybe it's just scaling. Maybe we just need to train bigger. Maybe it is something that is very simple. A bright student might say, what if we do this? Try it and immediately get a solution. Things have happened like that before, so one should not be dismissing that. But generally, there is an interesting problem here, that common sense comes out of interacting with the actual world, knowing how it's normally behaving. And of course, our machines are not normally living in the real world. The language models are living in an infinite library of everything written on the internet. They have never seen a color, yet they can actually do color naming and answer questions like, so is turquoise closer to green than to red? Even though they don't understand color in our sense, they still understand how color is being used and know enough color usage of turquoise to say it must be closer to green. This is interesting because there is a lot of common sense that you can just acquire by reading the internet. A lot of it is also crazy common sense. Indeed, it turns out that since there's so many conspiracy theories around, that quite a lot of the language models do not exactly believe conspiracy theories, but they can very easily recount conspiracy theories and use them as explanations. You can get them to stop too, which is kind of an interesting thing. You can ask them to give a plausible and truthful account for what happened in 9/11, and then they don't give you a conspiracy theory. But we have this interesting problem that their sense of common sense is very different from ours.
Yeah, and I mean, it's very interesting to see the parallel with humans and machines, the way they learn, because when you say sometimes transfer learning is something we do very well, it's true, but I think sometimes we also see humans we say, oh, this person is very good at reasoning, so they're good at math, calculus, maybe they remember names very well, but they're going to lack some other things that, for example, they might be terrible at learning languages somehow. So there is some sort of failure of transfer learning, that they learn some things, or sometimes people are very good at languages and not good at with numbers. Maybe we're going to have different kind of AGI that are good at a certain, like a set of big tasks, and they might not be able to learn another set of tasks that also AGI can learn.
I think general intelligence is, of course, supposed to be able to learn anything, but quite often we don't want general intelligence. In fact, we want specialized intelligence. Humans are able to do anything humans can do, but it typically takes at least 20 years to grow up a human to be able to do the job. It's a very costly process. And quite often we like to automate things by replacing the generalist human with a specialist machine. If you want to paint a car chassis, it's probably better to use an industrial robot, not just for safety and that it's a bad job to spray paint cars, but simply you can make much more cars painted that way. If you want to do writing, well, you can have people with a quill, but it's better to have a printing press. And similarly, we might use AI. Once we have a fairly general AI, we might then specialize. We distill it down to only the task we want to do. Indeed, this is a very different paradigm from how people often think about AGI as some human-like entity or maybe a little black box or a robot. It's a very isolated system, but it might very well be that we end up with AI that's more like the cloud. Lots of libraries existing up in the cloud. And if I want to make a smart application, I link in the human interaction library that creates a friendly interface, and I connect it to, let's say, the game development library that invents games on the fly, and another that is a graphical design artist library that makes visuals, and put together something that talks to you and asks you what games you want to play and that invents a game for you. Each of the parts here is not generally intelligent, but it might be a very useful and delightful app if I do my job right and they're trained in the right way. So we might end up with a world where there's a lot of intelligence, but not necessarily beings being intelligent. Or perhaps the entire cloud is in some sense now forming an intelligence, except that it's not a goal-directed entity. Traditionally, when we try to think about AI risk, many people immediately latch onto this goal-directed entity as the risky one. They see the Terminator as some kind of physical threat, or they imagine Skynet, this diffuse intelligence that is opposed to humanity and is trying to do things using whatever tools are available to stop people from surviving. But you could also have a world where there is a lot of intelligence that can get connected to whatever goals exist. And that's almost as dangerous as having one monolithic superintelligence, because now it's not just that every crazy or malicious person can get their powers amplified by AI. You also get emergent phenomena. We already see this with simple bots. For example, in the Amazon marketplace, there are some book-selling bots that don't own the books that we're trying to sell to you. They just know where to buy them, and then they try to sell it to you for a slightly higher price. In the case I'm thinking of, two of these bots were looking at each other. Both were considering the same book, which was the second volume of Anatomy of a Fruit Fly. It's a used copy. And each of them noticed the other one is selling it for this price. I'm going to sell it for a slightly higher price. And then sooner or later, some stupid human will buy it. Or rather, this was what the programmers were thinking, because these were simple scripts, no intelligence whatsoever. But since the two bots were watching each other, they were rising the price endlessly. So in the end, they were offering this rather bad book, well, not necessarily bad, but at least not very interesting book for $6 million. And that's the kind of emergent stuff you get using normal bots and scripts. Now, imagine that you also add a bit of intelligence, a bit of artificial creativity, so they try different things, including, of course, that it might be very valuable to hack other robots and systems to convince them to buy your product. And you could end up with a very dangerous mess. But there is no malign will. It's just this emergent disorder that moves everything in some direction. And if it's a very intelligent disorder, it might be very hard to stop. So I think this is a very tough AI safety problem. And it's very different from making a well-behaved robot or a software program in one computer. That one is at least somewhat well-defined. We need to figure out how to align its values. The problem with this marketplace that has emergent behaviors is that we want the market to have values. This is something I'm doing research on together with the AI Objectives Institute, where we are trying to understand the interactions between markets and AI. Because in some sense, you can say that companies are artificial intelligences. It's just that they're not running on computers so much as they're running on human minds and pieces of paper. And of course, many people will say, yeah, some companies are very badly aligned with human values. They're doing bad things, even though no person inside the company really approves of it. You can get bad emergent effects from companies and markets too. And I'm saying that as a very happy neoliberal who actually likes markets and capitalism quite a lot more than most of my more left-wing friends. But the interesting question is, if we have these complex adaptive systems of markets and companies, and we have complex adaptive systems like artificial intelligence, and we both of them seem to have value alignment problems, maybe there are some rules or methods that work on both domains. Maybe we can learn something valuable here about how to set up systems that actually are human aligned. What do we know in markets that we might apply to AI safety? Are there AI safety tools we might want to apply to companies? How do we set objectives that are good? Because even if we succeed in making AIs that are value aligned enough that we can live with them, that doesn't mean that we're pushing the world towards a better place. We want to figure out ways of creating that dynamics that actually move us towards better situations.
It reminds me, I think what you explained a little bit, this cloud of different systems. I think Singularity Net by Ben Gersel is trying to do something like that, if I remember correctly. But yeah, I'd like to come back to this, to the transhumanism and the connection between AGI, AI safety and transhumanism, because it seems to me that a lot of transhumanists are interested in AI for different reasons, and also the risk of AI. The Future of Humanity Institute came from Nick Bostrom and many other people thinking first about existential risk. They kind of pioneered this field. What is this connection between transhumanism and AGI and existential risks?
Transhumanism in the 1990s, when I came into the field, was extremely techno-optimistic, and I still think it is. But it was the techno-optimism that relatively soon we are going to get these awesome new technologies and they're going to transform the world to this crazy, fantastic, wonderful, better place. At least it's going to be better by the weird ideas we have about human transformation and self-expression. that still involved thinking about that the world could become very different. And this is, of course, where many transhumanists are different from mainstream futurists or even normal people. Because most people think about the future, see the future as a continuation of the present. There is going to be similar things, maybe some flying cars, maybe a bit more climate change, but it's not going to be ultimately totally different. An end to aging is kind of too radical to countenance in that way of thinking. Transhumanists say, yeah, but things might be moving in an exponential way. There might be phase transitions. We might create superintelligence. We might solve in aging and get to longevity takeoff velocity. So the future could actually be really, really weird, and that's a good thing. Now, if you accept that line of thought, you still end up with this disturbing realization that the future could be weird in bad ways. When you, as a transhumanist, try to talk about your ideas, quite often people push back by talking about how they could go wrong. And if you're intellectually honest, you realize that some of these critiques are not entirely unfounded. I think many of them are wrong, but many of them show that, yeah, things do occasionally go wrong. Indeed, we have seen in the past that many of the technologies that have had very good effects overall might still have side effects or complications that have been problematic. So that means that the idea of an existential threat is not unthinkable if you're a transhumanist. I remember vividly reading Nick Bostrom's 2003 paper that introduced the concept of existential risk on the train going to a transhumanist conference at Yale University. And I didn't like it at all, because to me it was, of course he's making a good point about that there are big threats to humanity, but this is going to be used by Luddites to try to slow down technological development. This is just annoying. Then gradually I realized that actually he's got a good point. If we go extinct or end up in a permanent dystopia, we have failed at the positive transhumanist future. And we can envision ways things go really badly wrong with these powerful technologies. So at that point, it's not a hard step as a transhumanist to say, yes, the future is likely to be awesome, but there are a few risks here that we need to deal with. If you're an optimist, of course, you say the future is worth saving, and I think we can save it. More normal people have a harder time saying the world could end. Certainly, a lot of people like being fashionably gloomy and talking about the imminent demise of civilization. People have always been doing that. Nobody seems to be planning that much for it, except for a few preppers. I grew up in the 1980s, and this was during the most dangerous part of the Cold War. There were pop songs on radio about nuclear war. And I remember lying in bed thinking the missiles might be in the air tonight. And indeed, it turns out that the close calls during that era were indeed frighteningly close calls. Yet people lived on and kind of ignored largely the enormous threat that was actually there. So the assumption that the future is going to be normal means that you also are shying away, not just from the transhumanist utopias and the weirdness, but also from the existential risk. So it's not a coincidence that several people involved in setting up existential risk as a research field came from transhumanists. Nick Bostrom, as a philosopher, was thinking about extinction risk because he realized if we go extinct, all the possible futures disappear, and that has a big impact on value. Elias Yudkowsky, that I mentioned earlier on, he was hoping to get singularity more quickly because he wanted to save people right now. But then he realized that a bad singularity is going to kill people instead. So we need to get things right before we get to the singularity. And then once the field emerged, of course, there are normal people in the field coming in from nuclear disarmament or thinking about biosafety, and they might think that the transhumanist angle is a bit crazy. But I think there is a nice synergy because thinking big and radical is useful for exploring domains where we have a little experience. Once we have a lot of experience with what works, what doesn't work, you can actually focus on that experience. But thinking about unprecedented disasters or new technologies, you actually need this wide-ranging thinking. And then, of course, you have to engage in a lot of academic discourse to try to figure out what's actually there. Is there actual risk? Can we put probabilities on it? Can we take steps to reduce the risks? But transhumanists have been quite instrumental in getting existential risk onto the map and also trying to unify the different forms of research that happens for other global disasters. The nuclear disarmament people and the peace studies people, they were kind of talking to each other, but they didn't realize that they had anything in common with the volcanologists thinking about supervolcanoes. And certainly they did not think that the climate people had something to tell them about nuclear winter. And by linking together this community, we can start looking at ways of reducing risks. For example, I'm also involved with an organization called AllFed, which is a non-profit thinking about feeding everybody in the case of a global disaster. You can get an agricultural disaster by a nuclear winter, or a volcanic winter, or an asteroid impact, or even certain agricultural bioweapons. In which case we need to figure out emergency food really quickly on a really vast scale. That solves a lot of different risks, so it's worth researching. But this very practical research, some of it is about how to do kelp farming or making greenhouses in the tropics to at least allow crops close to the equator. These things come out of a consideration that goes on this vast, grand scale transhumanism normally thinks about.
Fascinating. One question about the singularity. What are your views on the singularity, especially the risk that AGI will quite suddenly go far beyond human intelligence? Or do you have maybe another definition of singularity? But the idea for most people who say that the singularity will go very fast is the idea that AGI will be able to improve itself. Is that reasonable thinking?
The idea behind the singularity, as Vernor Vinge defined it in his 1993 essay, is that you have an intelligence explosion. You have machines that are getting better and better at various human tasks. And one human task is, of course, making better machines. So now you can make machines that make themselves better. And that is how you reach superintelligence. And then Vernor Vinge, being a professor of computer science and a science fiction author, said, and we can't predict anything beyond that point. So this is actually three different things that are combined. A self-amplifying intelligence explosion. That term, by the way, was coined by I.J. Good in the 1960s in a much earlier paper. And he might very well have discussed it with Alan Turing back in the 1940s and 50s, because in Alan Turing's thinking, there is also this idea that machines could be self-improving and become very powerful. And he also, even Turing noted that that might happen on machine development timescales rather than human timescales, which might mean that they leave us in the dust. But Vinge's idea also contains this idea that you have superintelligence. So if you talk with Ray Kurzweil, you will find that while he talks about self-improvement, he generally tends to assume everything is growing exponentially. There is not that super fast takeoff that you find in intelligence explosion idea, but he still thinks the superintelligence defines the singularity. Now, other people have slightly different definitions. But I think you can find various components that are not necessarily linked to each other. In my own work on this Grand Futures book, I'm talking about many things that I expect to be post-singularity events, yet they're totally predictable because even superintelligences are bound by the laws of thermodynamics. So there are certain limits that allow you to make predictions. There might also be forms of singularity that are softer or harder. There might be a phase change, for example. You could imagine a society getting more and more capable, and eventually you have a joint superintelligence emerging. So I have another paper where I'm listing a typology of different kinds of technological singularity. But getting to the intelligence explosion one, because I think that's an interesting challenge, we have seen a kind of intelligence explosion happen with human society. So humans, presumably our ancestors got smarter and smarter through random mutations. And then something happened about 150,000 years ago or so, when we suddenly just went out of Africa and took over the world. And that might have been language. It might just have been that we could communicate in an open-ended way with each other. And suddenly the tribe could perform tasks that no individual human could do. And it could also start remembering things beyond a human lifetime. Suddenly we got a cumulative culture, and that allowed us to transform everything. Except that, of course, on a human timescale, this intelligence explosion was too slow to see. It still took thousands of years. So I think the tricky question is, do we expect to see a really rapid on a human behavioral timescale singularity with machines? And you could imagine, of course, a computer rewriting code, making better code, and then things happen either on the software timescales, which might be the question of minutes, or maybe on the timescale of Moore's law, where you get a doubling time every 18 months, which is still somewhat in the realm where humans might realize something weird is happening. Maybe we should pull the plug or do something about it. While if it's minutes, nobody will be able to notice what's going to happen before it has already happened. And we don't have a good theory for this. Now, current machine learning is very compute and data intensive. So training actually takes weeks, even on big data centers. And that is because we're running a lot of data through a lot of processors again and again and again. It's a refinement method to finally end up with a few gigabytes of neural network. That neural network contains a lot of knowledge. It's fascinating to note that the stable diffusion neural network, it's about 4 gigabytes, and in some sense, it knows all of human art, or at least the kind of pictures you find online. It knows a lot of artists and art styles and visual tricks. Basically, that is a compressed knowledge of the world, and it's just 4 gigabytes. I can easily have it on a little thumb drive and wave it around. Just like the core part of current human civilization probably fits onto my 4 terabyte portable hard drive. So in some sense, it might be very small, very compact, but refining it to that state takes a lot of time. So I think we don't have a good theory to say that this cannot happen on a rapid timescale. I suspect that it will happen on longer timescales because quite a lot of important knowledge exists out in the world in form of physical things or physical interaction that you need to go out and interact with. It's not just enough to sit in your virtual library or the AI sits in this virtual library and cogitates and figures out the perfect rational plan. While that might appeal to many philosophers as a dream of how things should work, I don't think it's how it actually can work. So the technology actually needs to iterate itself. Presumably, you need to build better computers to run a more powerful AI. And that takes time. You need to order the components. You need to do that. And I also have a feeling that you actually distribute a lot of the tasks, which means that humans and human institutions are going to be involved. And a lot of the ability to make skill things are going to reside in many actors. So I'm generally on the slow and soft singularity side. But that doesn't mean that this is going to take thousands of years. I can totally envision that it merely takes a few decades. Now, that is still a long time scale compared to a human life, maybe. But it might be something that happens during a human lifetime. You might start out growing up in a normal world, and by the time you're 80, you're living in a world dominated by superintelligence. That's entirely possible. Also, it might be that the important parts are very different from what you would expect. So, for example, one interesting book is Robin Hanson's The Age of M, where he discusses the economic and sociological implications of being able to scan brains and run computer emulations of them in big data centers. He's arguing that this is a way of getting software intelligence without getting artificial intelligence right. There are big, interesting scientific and philosophical questions about whether you can make software people like this. But his main point is he's working out in grandiose detail what would likely happen in this setting. But if you read between the lines, you realize that this fast-moving software society probably doesn't last more than a few months in outside time before it has turned into something completely different or invented artificial general intelligence or done something else. So acceleration can be very surprisingly fast. So this was a long answer that actually is summed up to I don't know. But I also think I can fairly certainly say we don't know. I don't think we have the tools right now in theoretical computer science or psychology or artificial intelligence or even economics to say something about what the limits to these growth rates are. Economists tend to say They're probably much slower than you computer guys are saying, because we have a big economy with a lot of minds trying to make things grow faster, and not even the Chinese economy, when it's growing at its best, is that fast. On the other hand, the computer people say, yeah, but you're underestimating what happens if you can make better minds. And look, your standard endogenous growth models, they blow up to infinity if I put in robots. To which the economists respond, yeah, that's why we don't actually trust those endogenous growth models. They tend to either predict the economy blowing up in a singularity or stagnating. And actually, it's kind of stably, exponentially growing. So we don't know yet.
If I can interrupt you, if I understand correctly, you don't think that there is a big risk that one day, let's say, only software, a big computer with only software, will suddenly improve itself because it needs to have information from outside, let's say.
I think that is a correct description. But I think it's also not just the information, it's also about knowing what is useful. One of the weakest points in current AI is that it doesn't have a good way of evaluating whether something is good or bad. In computer image generation systems, pictures become better if you prompt it by saying a beautiful picture. If I go to an artist and tell him to paint a particular painting, or tell him to paint that painting, but make it beautiful, the difference is zero. No human will actually make a picture better by being told that it's supposed to be beautiful. We always try to make it as beautiful as we can. But that's not obvious to the AI. So actually saying that it's supposed to be a beautiful, impressive picture rather than a meh picture is relevant information for it. And when you want to make a self-improving system, it actually needs to have a sense of what improvement means. And in some cases, that's very easy. Code that runs faster, uses less memory, that is more robust. Except that these three different things might be opposed to each other. And for making something smarter, it needs better definitions of intelligence. And while we might have some theoretical definitions that matter, there are many practical forms of intelligence that such a system would need in order to become very powerful very quickly. That it's not obvious to it that it needs to acquire. And I think this might be one of the important limiting factors, acquiring a sense of what to aim for. This is, of course, what some critics say, that's why we're never going to do it. And I think that's a mistake on the side of the critics. But I do think it's true that typically you get systems going off in one direction, optimizing for one thing, when you actually need to have a combination of things to be truly successful.
There is also another trope, I would say, in futurism and transhumanism, is this idea that there is at some point some sort of fusion between human biological beings and artificial intelligence, and we can become some sort of symbiotic species. Do you think this is a likely or plausible scenario?
I think we are already approaching that. Indeed, yesterday I was giving a talk at a virtual conference for brain-computer interfaces, and people are certainly linking human brains to machines in various ways. The most obvious thing is brain pacemakers to help people with Parkinson, where you replace a faulty function of the brain by adding an input. We also got systems for reading brain activity and using that to control machines, mostly useful for prosthetics. And people are trying to achieve closed-loop neural interfaces that both send and receive information. And right now, this is useful for rehabilitation and helping people with some disabilities. But on the other hand, part of our minds are already residing in technology. I am a believer in the extended mind hypothesis that says that many parts of my mind are not so much in my physical brain as existing on my smartphone. Knowing what I'm going to do today, I don't know it in the sense of my biological brain, but it's in my calendar. And my phone will remind me when it's time what I'm supposed to be doing. That means that my phone is in some sense already a part of an extended self. And one can, of course, then argue about where the boundaries of this extended self are. I would argue that I regard Wikipedia as part of my memory, which also means that there's a lot of anonymous international editors editing parts of my memory, which is mildly disturbing. But this fusion is limited right now by several factors. One is it's kind of risky, painful, and expensive to put anything into our bodies. Why is that? Well, the immune system is very effective in getting anything that's not us out of it. And biology is squishy and complicated and changes, which is very problematic to interface for with our current technology. But our technology is developing. We have advanced tremendously in the past few decades in doing this. We're getting better biocompatibility. We're getting better surfaces that link to neurons. We're getting much better at interpreting their signals. And we can even send signals back using, for example, optogenetics that allow you to use light signals instead of electrical signals to trigger neurons. So that is getting better. We're also making biology that is more technological, like synthetic biology. So over time, it's pretty obvious that we are going to get better and better at this, and it's going to be easier and easier to do interfacing. It might still be a high threshold before you actually get a brain implant. And figuring out what the killer application, as we say, is for that brain implant is going to be tricky. I have a feeling that it's not going to be so much to have an implant to do web searches or act as your phone, because you do web searches without going to the hospital. You can use your phone and upgrade your phone easily. You can't do that with a microchip in your head. But it might be that we want the microchip to control a weight set point or control sleep. And then once you put it in, you want to probably to be able to have a little preferences menu where you can modify a lot of your internal states. And once that technology becomes going, then people are going to make it cheaper. It's going to become safer. And eventually you're going to integrate more and more. Where does this end? I think we're already a technological species. We're living ensconced in a very artificial environment. Even a wooden hut in the forest is an artificial environment. And of course, the vast majority of people are living in cities, gigantic machineries for living. Most of us live in houses full of technologies that augment our cognition, augment our health, help us function better. But we're putting more and more of that into our bodies or creating interfaces that make it easy for us to exploit the technological sphere. So it might be that we spread out. We both get technology inside our bodies to enhance our life as embodied beings. We also put more and more of our mind and feelings into our environment. I think many of us live a lot of our social life today on social media. And in some sense, many of our feelings might be on Twitter rather than in our facial expressions. And the final effect is, of course, that we might get this interesting blurring. Eventually, we might end up with, well, my current biological body is breaking down. I'm going to get a new one and make sure to transfer my mind either by moving the brain or moving the software in my brain or something else into that one. Now, some people are also arguing that this is the way of handling the rising artificial intelligence. So either we enhance ourselves so we're smarter than it. I think this is not going to work because our thinking is still going to have a pace set by our brains. And signals inside neurons move essentially at the speed of sound. They're electrical, but they don't go that fast. It takes milliseconds to send a signal from the one side of the brain to the other one. We can't really think as fast as a machine can using pure electricity or optics. So I don't think enhancement is going to be helpful against AI, although it might be good for us. Similarly, you can say, oh, if you can't beat them, join them. If we become cyborgs, then we are going to be on the winning side as the machines rise. But that's also a bit problematic. If a badly programmed AI turns the universe into paperclips, that doesn't mean that the cyborgs that get turned into paperclips were on the winning side. Yeah, they had some metal parts that made for very good paperclips, but that doesn't mean that we're on the winning side. Being on the winning side means having a causal link to the decision-making that shapes the world. And maybe being a cyborg can help, but not in that sense of just being a cyborg. And that is the value alignment part. I know what I like, and sometimes I can explain why I like it. Quite often, I just know it from my experience and my personality. And a lot of my likes are very typical human likes. Some of them are individual. That would be very valuable if I could get AI systems to understand. and I can try to explain them, but I'm not enough of a poet to explain why I love the people I love, etc. So it's going to be tricky. But now imagine that I have a brain implant. So the AI system could check, I'm going to try to do this. Would Anders approve? And it checks basically, would Anders approve of me pushing a little old lady into the street to get run over by a truck? No, he is horrified. Okay, let's not do that. Let's help her over the street. Is that good? Anders approves of that. That trivial feedback is already useful training data, except of course that it's not enough. You actually want to understand why I approve of helping little old ladies across the street. There is something called compassion. There is various ideas I have about social bonds and responsibilities and liking people that then the neural implant might allow me to explain better to the AI system than any amount of conversation. And this is where I think the merging with the machines might be helpful for value alignment. It still might be that it's enough to talk to humans, or just look at whether they're smiling, or just read enough human literature. But it might be an extra way of safeguarding things.
Yeah, one of the problems would be what people say and what people feel is something else. But yeah, but continuing for questions concerning, let's say, the health of human beings, how likely is it for you that AGI or only AI will help us to find a way to defeat aging? You know, that's one central question for many transhumanists, especially for me. Yeah, in let's say a relatively close future, like 10, 15, 20 years, one member of the Association Française Transhumaniste, Technoproc, was proposing this. Let's create a kind of almost AGI who has the possibility to work in a lab and to make experiments on mice and to think about all ways to defeat aging. Yeah, that can be one idea.
So people have been thinking about using machine learning to make medicine better for a fairly long while. So in the early days, the idea was, let's do molecular simulations, and that's going to help us screen various drugs, or rather drug candidates, to try to find the ones that are likely to be worth actually making in the lab, and then we can try them. This has generally not turned out to be quite as good as it looked from the start, because it turns out that the number of possible molecules is, of course, near infinite. So you can always make a very, very long list of candidates, but you still need to do that testing. You need to make the molecule, which is sometimes hard, and you need to test it. And most molecules don't work for what you want because of complicated reasons we don't understand. So people said, okay, maybe we can work on making the synthesis part better. So there are now AI systems that are getting better and better at coming up with ways of doing chemical lab work to synthesize molecules. There is also, of course, work on systems biology trying to simulate the effects of various interventions on cells and on organisms. Each of these is not powerful enough to do anything important about aging, partially because we don't actually have great models of aging that would work in a simulation. And I think we need to have a really good simulation system for AI to really work well, because then you can have a very rapid feedback loop where it can do experiments in simulation, endless numbers of them, and then come up with an actual experiment that you do in the lab that you can then use to update simulations and strategy. We are certainly seeing an amplification of ability to search through this vast chemical space in the drug industry. We're also getting better ways of interpreting the data, but it's still rather early days. And I think, again, it's very hard to predict where we're going to end up with this. What I really would like to see is a way of taking a biological system, scan it somehow, pick it apart, and then turn it into a computer model of itself. I'm, of course, mostly interested in doing this for the brain. But you could imagine doing exactly the same thing for biological tissue, to actually try to make really accurate biological models.
I would say to make digital twins, actually.
Yes. Because once you have a digital lab rat that actually shows aging and so on, you can do a near infinite amount of experimentation to try to figure out what can I do to make this lab rat age more slowly. Now, in order to do that, you need new technologies, both in getting data in the lab and then learning from it. But I think that is a worthwhile pursuit. Meanwhile, there is a lot of impressive things happening in the AI domain. For example, AlphaFold, one of the things coming out of Google DeepMind, is a system figuring out protein folding, which used to be believed to be an immensely difficult problem, and it's by no means easy. And humans have become better and better at it up until the point when AlphaFold showed up and more or less beat all existing humans, even the experts, on doing it, and can of course be automated. So now you're basically getting models of most protein and the conformation. That's not enough, of course, to make an anti-aging drug, but it's a useful tool. So what is happening right now is we're getting more and more tools: automated chemical synthesis, automated simulation, automated protein folding. And you might then connect that to other systems that plan experiments, make hypotheses. Now, imagine that we had a superintelligence tasked with figuring out a way of handling aging. And that it's also aligned, so it doesn't just solve it by, well, if you poison everything, then it's not aging anymore, and then I solve the problem. You really want to get that part of alignment right. But if it's trying to figure out how to get longevity and health by slowing down the aging process, it needs a lot of these other tools. That's going to take a while to develop. But this is, of course, tools that are useful for a lot of different purposes in the lab. So even if somebody is not a transhumanist, they might still say, yeah, automated chemical synthesis, that would be so useful. I don't want to have a lot of postdocs messing up my lab trying to make this molecule. I just want a robot to do that. Oh yes, automated experiment design. That sounds like a really useful thing, at least for the simpler experiments. I'm going to deal with the smart experiments and the big insights. So I don't expect that we are going to get there super fast, because aging is a messy problem. In some sense, if aging had been like winning in chess, then I would have been very optimistic. You just need to make the right moves, and in general, you will win with a very high probability. But in the case of aging, we have this messy system that has evolved, and is probably very little that you actually can understand, because evolution is not optimizing for some deep purpose in our cellular biology. It's just making things that work well enough to produce offspring that survive on this planet long enough to be a species. And that means that the reasons we end up with aging are a lot of messy things deep in our metabolism and genome that don't really have any neat, good explanations other than, well, evolution ended up with this. We might have this wonderful bottleneck of the hallmarks of aging, where we might actually be able to do interventions that work. And this is where I think AI can be very powerful. But it's still a very messy system to deal with. This is where I think there is a chance of getting breakthroughs. But I don't think we're ever going to see a superintelligence say, yep, I figured out aging. There is this simple, nice explanation. You must can't understand it because it's beyond you, but there is this short, nice explanation. I don't think aging actually has a short, nice explanation, except that evolution doesn't care about you after you have your kids. So that's why there is a lot of weird complexity in biology that makes us work worse in old life. But I do think that we are going to get the tools, even if we don't get AGI. But it's also going to be an uphill struggle, because many of these tools need to be tested. We need to actually run the experiments in the lab. And many of them might have complicated side effects that take time. But that's just how life is. I think there are parts of the world where intelligence can easily win. And I think there are parts of the world where intelligence has no chance whatsoever. No matter how smart a computer is, if it's falling down an elevator shaft and doesn't have any manipulators, it's not going to be able to survive falling down the elevator shaft. But there are these intermediate situations like aging where I think you can, with enough intelligence, actually solve important problems and get good enough solutions to actually make a very big difference. But this is, again, something you might want to take bets on. There are some people probably saying, no, I think aging has a simple solution. Anders is wrong. There's going to be this nice little one pill. And others say, no, aging is super fundamental and you can never get rid of it. And they, of course, would bet against it. I think both of these groups are totally wrong. I think aging is one of those intermediate messy problems. It's a bit like, how do we get peace in the Middle East? It's not even a really well-defined problem in the case of Middle East, but there are still things that make things better. In aging, I think there are things that are much better. And I think we are probably going to find some very cool things once we have machine intelligence effectively doing lab work for us.
And if I may add something, so I totally agree with this idea to have, some people call that digital twins, but one of the big problems when you are doing that for humans is that big data for big data concerning humans is now more difficult to obtain than before because of all of these regulations, the GDPR, privacy, and because of also private interest, commercial interest. So there is one philosopher, probably you know him, Stefan Sorgner, who says that one partly solution would be that all digital data concerning health should be accessible to all scientists. Do you think that could be a part of the solution or not? Because it's fascinating that, like you said, at the moment there is no artificial intelligence really working great for discoveries for longevity.
I do think we need to think through how we're handling privacy, because right now privacy has become this weird symbolic question that is not really grasping at the substance, but rather than at its forms. So we all end up clicking, yes, we accept the cookies on every single website without thinking. That doesn't enhance our privacy. Being constantly reminded of GDPR might be relevant for the GDPR bureaucrats, but it's not actually enhancing our privacy. And similarly, there have been cases in Sweden where patients have not been allowed access to their own healthcare data by the information providers because of privacy concerns. What if they publish their health data online? Then that breaches their privacy, so they're not allowed to see their data. That was stupid, and it's kind of missing the point.
It's a totally crazy situation indeed. Yeah, but also it's an alibi also from for many doctors, private companies, and so on. They just answer, okay, there is GDPR, but okay, but I totally agree with you.
But this kind of privacy theater, of course, has this actual problem that scientists generally are surrounded by rules and have to work inside institutions that are enforcing the rules, which is one reason why the private sector might be doing much better. Now, in many countries, of course, healthcare data is usually held by government healthcare organizations, so the private sector might not be able to easily get access to it. But much of our other data is totally accessible, and many people are feeling very disquieted by that. Now, what is the solution? Saying scientists could get access to the healthcare data is itself not enough, because, well, technically I'm a scientist, but I'm not doing life extension research or medical research. I do weird ethics. If I got access to your healthcare data, I would probably use it for some weird philosophy paper. Is that what you want your healthcare data to be used for? Maybe you want that, but many others would say, no, I want my healthcare data to be used for important healthcare applications. We might still set up regulations in different ways and giving access. And that, I think, points at what we actually want to do, and that is structured transparency. So there is this general idea that maybe some things need to be private. Nobody else should be accessing them. But obviously, your healthcare data, your doctor needs to access to them. So there needs to be some channel from the opaque box where you keep your data. Others say, no, this is bad. We need transparency. And essentially, all information should be free, which is, again, leading to a lot of problems, because there is quite a lot of information about the private life that I think we very legitimately don't want to be very open. What you actually can do is, of course, to structure this. There is no reason why you actually can't set up things so you can share data in a useful way. Right now, for example, there are various methods of anonymizing data and put them into a database so a researcher can access the health information without finding out who it is. This is not easy because there is actually rather subtle issues. if you're sufficiently unique, people can, in theory, figure out who you are. And I think this is where the privacy theater comes in, because in most cases, this doesn't matter. Most scientists are not interested in hunting for celebrities in their data set. But still, there are ways like differential privacy, which is a set of very clever methods to get data out of big healthcare data sets without actually risking people's privacy. And these ones are technically complicated, but that can be handled by the machines. But you need to set up the institutions and methods of access in the right way. And you can structure the transparency in many different ways. In many countries, it's easier for a police to access genetic information than it is for scientists, for example. Because if the police say there had been a crime committed, they can go and look in DNA databases much more easily than the scientists can. Is this appropriate? It seems to be that actually we might say that if there has been a crime, it's okay for the police to look for genetics. But if there has not been a crime, it should not be possible for the police to look for genetics. You might want to set up the system like that. Similarly, if I have a valid research question, I should be able to check genetics, but maybe I don't get to see who the people are. These are issues about data management and design that are technically fairly complicated. And that is the problem, because right now the privacy theater is all done by decision makers who don't understand computing, statistics, data science, and how science is done. So we get rules and regulations that are not really fit for the purpose. And that means that as long as that's not fit, you're not going to get any development of the tools that are actually helpful. But if we can demonstrate some of the tools that are privacy enhancing while giving the right kind of access, I think we can convince more and more political decision makers that this is actually a way of getting advantages.
So yeah, I just it's something I don't hear a lot from you. I guess is your assessment on global warming and more generally our negative impact on the environment, because at FHI and in general the X-risk community focus less on climate change, or at least the general trends, because it's not neglected compared to AI or biorisk.
So we generally have this formula of what projects and problems should we look at. And typically it's scale, neglectedness, and tractability. Look for the biggest problems. And this is why we're working on existential risk. And then there is this important issue of neglectedness. Is this a problem where there's already a lot of people working? In that case, adding a few extra brains to it might not matter very much. And climate change has been very much like that. There is an enormous community, big conferences and a lot of different departments working together to deal with climate change, which means that adding a few X-risk researchers to the domain doesn't seem to actually add that much to climate change. And also, from an existential risk perspective, climate change is small potatoes. For a long time, we were fairly convinced that it's kind of not irrelevant, but it's a smaller issue. It's making things worse, but it's not exactly threatening human survival. And we still think that's directly truth in that direct sense. It's very unlikely that you get enough climate change to actually kill people. Yeah, certainly heat waves and disasters and flooding and things like that are bad for people, and some people will be harmed and killed by that. But it's not likely to wipe out humanity. In order to get warming enough to wipe out humanity, you basically need a really absurd amount of heating, which is extremely unlikely in the current climate models. At which point some of us start to say, wait a minute, extremely unlikely. How many percentage points did you say? And basically, we ended up with, for a while, thinking, oh, maybe 1% probability that you get to this extreme tail. That's actually something that got us interested, because we found that now it was the climate community that was neglecting these extreme outcomes. They were very careful about modeling 2 or 3 degrees of warming and trying to explain why this really matters and why we need to avoid that. They didn't like talking about 10-degree warming scenarios, because they were very aware that this is very uncertain. It's based on a lot of modeling assumptions that we don't fully trust. And yes, it's super mega catastrophic, but we don't really want to make use of that because people will also point out that it's based on very uncertain models. While from our perspective, if there is 1% chance of something super catastrophic happening, we want to know more about that. We should be doing more studies of it. Now, it seems like in more recent data and modeling, the good news is that extreme tail have lost a fair bit of probability. There's still some probability over there, but it has gone down. The more updated models predict a bit more warming than we would like because we're not doing much against the warming, but also the uncertainty range has become smaller. However, there is another aspect that we're interested in now, and that is the systemic aspect of climate change. So while heat itself is not really going to wipe out humanity, you could imagine a situation where in the 2070s, there is a lot of people displaced because of flooding. And there is also agricultural problems because the changed weather patterns means that traditional forms of agriculture doesn't work in many countries. So you need to shift to totally different crops. And in many cases, you can't even predict which crop you want to plant this year because of fluctuations. And in poorer countries, it might be too expensive to get the new crops that can handle the changed climate. At that point, you have a world that is very stressed. It's not exactly that world is necessarily going to kick the bucket because of just that. But of course, we're going to be the normal international conflicts. And we can imagine that you have more powerful bioweapons available and more powerful artificial intelligence, new ways of doing military action using drone swarms. And we have a more integrated internet with various security problems. This systemic situation might be very fragile. Just imagine that you suddenly have a breakdown in the international financial system because something breaks in the encrypted bank transactions, and suddenly nobody can use a credit card to pay for anything anywhere. Don't worry, it's just going to take 2 weeks. During those 2 weeks, you probably don't have cash and you can't buy anything, including gasoline for your car or your tractor. That's bad. And by the way, you also have various other problems with climate. And at this point, you might also have a disinformation problem. At this point, you might imagine the domino bricks falling over. Basically, you have a complicated interdependent system that crashes. And because it was also under a lot of stress because of other factors, this gets much nastier. And then you can get things like normal warfare escalating to nuclear warfare and then people using bioweapons. And then you end up with an existential disaster, which is not because of one particular cause. It's happening because of everything. And climate was not the triggering cause, but it made everything worse. So this is a good reason to try to avoid having too much climate change, just like we might want to have better computer security so our transactions are safe. This is why we want to make sure that the international trade system can't crash just because a single boat gets stuck in the Suez Canal, etc., etc. So thinking about climate change as a part of systemic risks, I think is a better way of dealing with it as part of X-risk world. Of course, if you're really worried about early AGI leading to disaster, you might say, yeah, but climate change still takes decades to really bite. And I expect by that time, the AGI problem is going to either have resolved itself in a bad way and then it doesn't matter, or we're going to have fixed it and now we have intelligence on tap to help us solve all our problems. So if you really think that AI risk is a serious thing, you might still want to say, yeah, I'm going to focus on that rather than climate. The climate people, yes, good that we're working on it, but I'm going to focus on this. Of course, some real gloomy people might say, yeah, I think we actually have a nuclear war before we get to the AI risk. In some sense, nuclear war prevents AI risk and climate change. So the interesting thing is, in the existential risk and global catastrophic risk community, you have actually different views on which risks are most urgent. And I think that's a good one. We want to hedge our bets. If we just had a big conference and all agreed on this is the rank order and then start working on the top risk and ignored all the other risks, we would be much less prepared for the randomness and strangeness the actual world throws at us. You want to have a distribution of people working on these things. And I think climate is interesting because it's a systemic problem. I'm trying to start up a new organization to look at long-termist studies in Sweden. And one of the issues we want to look at is how do you handle systemic risks? Because we don't have good intellectual tools for them. We know really well on how to deflect asteroids. After all, the NASA DART mission even demonstrated that, yes, humanity can deflect a small asteroid a little bit right now. Because we understand the physics, we understand the technology needed to deal with that. We have some understanding about international relations and the great power wars, and we can do diplomacy. We can try to reduce the risk of nuclear war, although it's a much messier domain. But at least there are people working in that domain. We have people working on AI safety and AI capabilities, where it's somewhat well defined what kind of technologies are involved. We know that it has to be computer science, maybe cognitive science, maybe some economics and philosophy, but we know what disciplines are involved. What about systemic risk? At this point, it seems like everything is involved because everything is connected. We probably need to have economists talking to the climate people, talking to philosophers, and we probably need some network specialists, and we need logistics people. And basically, we don't have a good set of tools here because it distributes across the entire intellectual community. And that is a big problem. We need to invent better ways of working together on these big problems. And that's something I'm hoping to contribute on. I'm very happy that there are some people dedicating their life to one particular narrow risk. I can't bring myself ever to do that. But I like the idea of taking their pieces of knowledge and then also trying to see, can I link them up to other domains? Or the clever economic tricks to motivate intelligent agents to act in everybody's interest that I can use in AI? Can I use things from systems theory to come up with better ways of making political decision-making, handle complex disasters? Or are there tools in marketing that we can actually apply to get people to do the right thing in the right situation? Or defend against misinformation, and so on. It's going to require a lot of interdisciplinary work by a lot of people. But I just want to invite everybody to join us. The future is so bright and so potentially so much value and so much cool stuff there that is worth fighting for. It's worth fighting to your last breath. And it's worth fighting so you don't have to take your last breath. But I also think we need to be optimistic about our chances. Yeah, things are tough. Right now, people are very gloomy. But people were gloomy in the 1940s during the Second World War. People were gloomy in the Middle Ages. And we got through them. Maybe we're not getting through our future challenge, but we should give it a good try. And empirically, we know humans are adaptive. Humans are ingenious. Humans under pressure can come up with amazing things. Societies are good at not crashing. So I think we have reasons to be optimistic about the future and then aim at the most glorious, grand transhumanist future you can possibly imagine.
That's an amazing way to end. Yet I still have one more question that you can spend 10 seconds to answer yes or no, but I can't resist to ask that. Are we living in a simulation?
I don't think it matters. Maybe we're simulated, maybe not. But if we are simulated, what actions should be different? Well, if you believed that you were in a tiny simulation, like a really interesting podcast conversation, then your life is going to end as soon as you stop having the conversation. So you should just keep on doing it. Ask more questions, please. We need to keep ourselves alive. But it could also be a big simulation, simulating an entire civilization or an entire universe over billions of years, in which case, actually, you should just behave as if you were in the real universe. And if you don't have any knowledge about that or don't have any good statistical idea about where you are, it seems to make most sense to act as if you're in the real world. And then, of course, you might want to poke at it. You might want to do reality checks from time to time, but it's very unlikely that that's going to matter very much. So I think the real issue is we experience the world. We are hopefully enjoying the world. We should be doing that, and we should be trying to be good citizens of the world, no matter whether it's real, simulated, or something completely different.
Thank you very much, Anders. Is there something that you want to add, especially for people interested in transhumanism and questions related to long-termism? And also, what is the best place to have more information about you and about your great work?
So generally, I try to post links to my papers and explainers about them on Twitter. So I'm kind of easy to follow there, but that's also going to involve a lot of other random stuff. Generally, long-termism, I think the best book is, of course, Will MacAskill's What We Owe the Future, which I think is a great follow-up to his earlier Doing Good Better, which is about what we can do to help the current world. Generally, when it comes to transhumanism, etc., I think the best approach is always to read widely. And not just reading the people who like transhumanism. Sometimes it's very fruitful to read Francis Fukuyama's Broadside Our Post-Human Future, which is arguing against transhumanism. Mostly because every sentence you read typically makes you think, no, that's not right. This is why I believe opposite. But generally, I do think that today there are more opportunities than ever to read widely and also interact with people, ask questions, and figure things out. There was a phase transition in the early 1990s when transhumanists came onto the early internet and the web. And I think there have been another phase transition now thanks to social media. Maybe a more noisy world, but it's also a bigger world.
Merci d'avoir suivi cet épisode, c'était un véritable plaisir pour moi et j'espère que c'est partagé. Si ce genre de contenu vous plaît, je vous invite à aller sur la chaîne YouTube, notre site et d'écouter les autres épisodes du podcast Humain demain, mais aussi de la série La Prospective. Si vous voulez nous soutenir, vous pouvez le faire financièrement sur Tipeee, YouTube ou en achetant nos contenus premium sur le site. Mais tout simplement en partageant ou encore de nous écrire une revue ou un commentaire. C'est une façon simple et rapide de nous donner un véritable coup de pouce. Merci et à bientôt.
Le podcast
Humain demain.